Apologies, but the video sound went a bit dodgy at the end of that, so I'm going to start from question 11, which was the next one people found hard. For the first part of this, you're just going to have to learn... Sorry, let me just get to the right point. Question 11, there it is. So for question 11, for the voltage of a car battery, that's one of the ones from the notes quest, you're just going to learn that. It's normally about 12 volts. In the house, you've got 230 to 240 volts. And you can see that would be too dangerous in a car, so we use 12-volt batteries. To calculate the power, remember electrical power uses this awesome equation. So good, I'm going to put a nice red circle around it. P equals IV. Way to remember it is PIV, or some remember it as poison IV. Remember, I is current, V is voltage. So to find the power, we just times the current, 1.5 amps, times the voltage, and that will give you 18 watts. Remember, the unit of power is watts. What's going to happen if bulb was attached to a 1.5 volt cell instead? So we're going from 12 volts to 1.5, so the voltage is smaller. Now remember, that means we're going to have dimmer bulbs, so the brightness is going to go down, and the current will also go down because, yep, sorry, Mr. Garner, not thinking straight after 6 lessons. The current, of course, will go down. Less voltage means less push on the electrons, so the current goes down with a smaller voltage. Let's go to question 18 now, which is the other one people struggled with, and an important one, mass and weight. So remember, to calculate weight, you use this equation, weight equals mass times gravitational field strength. The mass of the astronaut is 78, and G, which gravitational field strength, is 10. So you just times those two together to get 780 newtons as their weight. So remember, weight, everyone says they're weighing themselves, they're not, you're actually massing yourself. Weight is measured in newtons, and you calculate it using that equation. For part B, it wants the mass and weight of the astronaut on the moon. Now, first of all, let's start with mass, because this is a bit of a trick here. Mass is the same everywhere in the universe. It's just how many atoms you have. So the mass of the astronaut will still be 78 kilograms. That does not change. What does change is the weight. So remember, weight equals mass times gravitational field strength. On the moon, the mass is still 78, as we just said in the last question, but the G, the gravitational field strength or pull, is only 1.7. So you need to do 78 times 1.7. That should give you a weight of the astronaut 132.6 newtons. So less. You can see that's why you weigh less on the moon, but you don't mass less. The mass is the same, but you can jump higher because you have less downwards force, less weight. Let's go to question 20. Good old Oscar skiing downhill. And we can see the forces labelled on here. This one's probably part of your weight, and this would be air resistance or drag. Remember, that always goes in the opposite direction to the motion. State the size of the resultant force. So, resultant force, what is that? Well, remember, resultant force is kind of the leftover force, the net force. So we've got 350 forwards, but 190 back. You take the two from each other, and that gives you a resultant force of 160 newtons downwards. And that's why Oscar's going to accelerate downwards. If the resultant force was upwards, that means you'll start going back up the hill, which would be a bit odd if you're skiing. At the time shown, Oscar has an acceleration of 2 meters per second. Calculate Oscar's mass. So we're thinking, this is an equation. Which equation has mass in, probably some sort of force in, and acceleration? Well, hopefully that looks familiar. Well, it's F equals ma. However, you need to rearrange this so you can learn the triangle. ma at the bottom, F at the top, because we need to find the mass. Current mass, that tells you that mass is equal to force over acceleration. Remember, this line means divided by. Force, well, this force, which force are we going to use? Do we use 350? Do we use 190? No. Remember, this equation is about the resultant force, so we use the 160 calculated in the last question. The acceleration, well, we're given that, so we just put that in as 2. So 160 divided by 2, either in your calculator or in your head, is 80. And remember, the units of mass are kilograms, as we discussed earlier. So 2 equations there we've just looked at, and 2 that you need to know. Weight equals mass times gravitational field strength, and force equals mass times acceleration. Learn them as triangles if that's easier, or just learn how to rearrange them using your maths. Either one, don't mind, but you need to know these 2 equations. Any questions from any other questions? Any questions from any other questions or any papers? Let me know, and I'll make a video about those. Keep up the hard work.